So we're trying to take a derivative, ln of 3x plus 4y. What should we do?
Take a derivative.
Thanks. How? All right. Yep. So this is implicit and it's chain rule. We know we're going to do the ln first. So it's going to be 1 over 3x plus 4y times the derivative of the inside. Okay. And so if we look at the derivative of the inside, that's going to give me a derivative of 3x would just be 3 plus 4 del y dx. Okay. So that's going to leave me with 3 plus 4 dy dx over 3x plus 4y. Now we got to try to get we got to get that dy dx over, right? Because derivative of y would be dy dx. Okay. Thoughts?
None at all.
None. Gosh. Struggle bus. I'll tell you what, let's do. I'm going to rewrite this. I think it'll help. Let's do. So 1 over. We've got 3 plus 4 dy dx. Okay. And if I distributed, that would give me dy dx is going to equal 3 over 3x plus 4y plus 4 over 3x plus 4y dy dx. Does that work? Okay, so let's move some things around. Let's move that dy dx term over, right? This is going to give me 3 over 3x plus 4y is going to equal 1 minus 4 over 3x plus 4y. I don't know if I'm helping myself any here. And then I've got a dy dx. So just pulled a dy dx out of both of those. We agree with that? Okay. All right. Y'all make me nervous there for a second. Okay. So dy dx is going to equal 3 over 3x plus 4y divided by 1 minus 4 over 3x plus 4y. This is nasty. Do you need a comment? All right, let me talk to myself. 3 over 3x plus 4y. Divide, I'm going to multiply. 3x plus 4y over, this is going to give me 3x plus 4y minus 4. All right, do you see where I got that? I got all that together. I got a common denominator here for this one. So this would have been 3x plus 4y minus 4 over 3x plus 4y. And then I keep change. I flipped it. Okay. And so then my 3x plus 4y is going to go away, and it leaves me 3 over 3x plus 4y minus 4, which is D. Just some nasty algebra right there. Okay, that's kind of going to kind of be our theme for today. All right, it's a little bit of nasty algebra. As we look into this last section, which to me, I'm not really sure it fits in this unit, but it is what it is. Okay, they had to put it somewhere. Here is your affirmation for today. Sometimes not getting what you want is a wonderful stroke of luck. Okay, I get to be here today. See you, beautiful people.
That's not luck.
All right. So today we're going to talk about describing behaviors of implicitly defined relations. That's why we did a little implicit differentiation to start. Oh, here's pink. What about us? All right. So far, all the curves we've analyzed have been functions. All right. We could identify critical values using the first derivative, evaluate the function to get the corresponding output. But what do we do with other relations where there are problems that want to be solved as well? So take a second and let's work through this. I think there are 6 questions to this investigation. So they're giving you this curve, x squared over 4 minus y squared equals 1. Anybody know what that is, by the way? It's a conic section. It's a hyperbola. All right, so this is a hyperbola. Hyperbola, not Lee. All right, that's from English, right? So this is a hyperbola. All right, so take a second. Let's use this graph. And just looking at the graph, where does it have vertical tangents? Where does it have horizontal tangents? If it has any, and then where is it increasing? Where is it decreasing? Just looking at the picture, okay? Go. All right, so there are 6 of those questions. So do that for me real fast. You can pull up with this group, so you don't have to be alone.
That makes me so happy.
No one calculus is alone in here.
You're not allowed to sit next to me. Go be alone.
Wow. Whoa. Wow. Oh my gosh.
Fine, you can sit right here. You can sit right here. It's fine.
That escalated quickly.
No, did you, no, it wasn't as cool as me making that half-court shot.
I'm not even gonna talk about it.
So, you're basically implying that I didn't back
I'm not even gonna talk about it because like I did so well that day. I'm surprised I did that. Anyways, what is this crap up for?
I know.
There ain't no horizontal tangent. Is that a lie? No.
No, it's true.
Booyah!
But there is, I think, a vertical tangent. Am I, or
Two.
Right.
because it is approaching those points, but it never actually loved taps.
This is all board. I don't know. I don't know how to define these vertical tangents. I'm gonna say nothing. I know there's diagonal tangents. These 2 lines.
I forgot about that. You know, I'm so right. But what is happening? I put plus over 2 for some
Which quadrant is this curve? Can Clayton and which quadrant is this curve? I don't remember how to number the quadrants, but I know that positive and
reason. 1, 2, 3,
negative. 1 and 2. Find dy dx using implicit differentiation.
You know
So
what?
we have x squared over 4 minus y squared. Okay. We're going derivative both sides. We don't do.
I just think that how I was gonna get this sort of. So 2y.
Yeah.
They don't. Basically, situation. Or maybe I'm just when in doubt, I'll just blame it on the algebra. That's all that matters.
Okay, so I forgot to do chain rule of the line. That's, my bad.
I mean, I saw the Y, and I didn't feel like squirting the whole shebang. So I did the, and that was when you find the root of the x squared over 4. I did the whole time. You know, it's fine.
It worked out for me.
Well, we both got the same answer. It's all that.
That's all that matters.
This is equation for y x coordinates. Certain questions. Let me see your answer. Let me see your answer.
Sorry, you can keep going.
No, I was just a little. I would see how I could get before we go.
Okay. That is different than what I would have done. I would have never even thought of that.
What? What?
It just means you're better.
It does.
Either that or I'm just genuinely exhausted.
Okay. Well, I guess it makes sense. You can't lose me on the front end, because then I can't get to the back end as more. And I am not gonna get to the end of the problem,
Okay.
because I got lost. And it's my fault. So it's your fault. Say it's your fault.
Okay. I'll take the blame. It's all good.
Yes.
No, I'll blame it on.
Blame it on the rain.
I'll blame it on that, what's his name? Like, something Waters.
You could blame it on the boogie.
Blame it on the buggy.
See, this is why we all get along, is because our brains are so everywhere. It's good stuff. It's good stuff. Good stuff. I think your bun looks really good.
It's very cute. It's not what it takes to collar. I think I'll get it. I have to put that time on.
That's a good point. I didn't think about that.
I've asked, literally, we have staff in there. And it's four of
surely
them.
there's
And
gonna
it's
be
students,
bug
they know what they're doing,
why.
they've had the class like all 4 years. And I've asked them every single day to help me, and they
Buzz knuckles.
because there's no one else in the class that's ever had it before. And yesterday, I asked one of them, he was like, who else needs help? And no one else raised their hand because they didn't want to have the class before. And he was like, oh, I guess you're on your own. Look it up on YouTube. That's so mean. It's kind of bad. But I'll go crazy and I'll help you.
Okay.
I hope he doesn't know. Should he tell on me?
All right, so let's talk about this one. So where do we have vertical tangents? What is a vertical tangent? Yeah, it's the vertical line. All right, so it's going to touch the curve. All right, so it looks like we've got them at -2 and +2. So vertical tangents. As x equals -2 and +2. Do we have any horizontal asymptote? You got me saying asymptote. Horizontal tangents? No. All right, so we have no horizontal tangents. Okay. Remember, those are ones where the slope would be equal to 0. Okay, so we don't have any places where we have that. All right, so let's talk about where is this curve increasing? All right, so as, let's see, let's read it from left to right. So it looks like we increase, what, there? And here. Okay, so in which quadrants is it increasing? All right, 1 and 3. And then if we're looking for where it's decreasing, two and 4. Okay, so it's decreasing in quadrant 2 and quadrant 4. Okay, all right, so now it asks me to find dy dx using implicit differentiation. So equation down. So my original equation was x squared over 4 minus y squared is equal to 1. So if we do implicit differentiation, that's going to give me 2 over 4x minus 2y dy dx equals 0. Okay, that's a 1/2 x. I'm going to pull that over, so it gives me negative 2y dy dx. It's going to equal negative 1/2 x. All right, and then if we divide by a negative 2y, that's going to give me dy dx is going to equal positive x over 4y. Okay, so there's my derivative. Did you get there?
I got there, I just went a little wonky.
Okay, yeah, negative 1/2 or negative x over 2 times negative 1 over 2y. So that's where that comes from. Keep, change, flip. So now, important question. How does dy dx support your answers to questions 1 and 2? So this is important. How does it fit? Okay, when we talk about increasing and decreasing with a relation, okay, what has to be true calculus-wise? Yeah, the derivative, all right? The derivative would have to be positive. So where it's increasing, dy dx would have to be greater than 0. Okay, so let's go back and let's look. Is that true? All right, are my slopes positive in quadrants 1 and 3? Well, let's look. Okay, if I look at quadrant 1, if I did my tangent slopes, are they positive? What about in quadrant 3? Are my slopes positive? Yes. Okay, they are. So it matches. Okay, so why does that happen in quadrant 1 and quadrant 3? Well, if we look at our derivative, what would have to be true for dy dx to be positive? What would have to be true about x and y? They'd have to be the same sign. So we increase when dy dx is greater than 0, which means x and y would need to be the same sign. Okay, so based on what my derivative formula was, all right, it makes sense that we would get quadrant 1 and quadrant 3. Well, let's see if that holds true for our decreasing pieces. For decreasing, what has to be true about the derivative? It has to be negative, okay? And so we said that happened in quadrants 2 and 4, all right? So what would have to be true about x and y for them to be a negative derivative, to have a negative derivative? They have to be opposite signs, okay? X and y, not need. Okay, which makes sense for quadrants 2 and quadrants 4, which is what we saw from the picture, okay? Good. Okay, so the same rules still apply, all right? Even though it's an implicit relation, the same rules still apply. The derivative has to be positive for it to increase. The derivative has to be negative for it to decrease, okay? Let's look back at the curve. When's it concave down and when is it concave up? Okay, so let's talk about concavity. This is a little weird, all right? So when we talk about concavity, all right, concave up means it would do what? Hold water, okay? So concave up, let me change this to that. So concave up is going to happen here and here. So what quadrants is that? 3 and 4. And then concave down is going to happen in 1 and 2, okay? In 1 and 2. Right, so that's where our concavity is. Right. So we are going to be concave, still in the highlighter, concave down, right, in quadrants 1 and quadrant 2, right, and then we're going to be concave up in quadrant 3 and quadrant 4. Now, let's go back and let's look, all right, at what's true in those quadrants. To both of those, that would be true, okay? What's true in both quadrants 1 and 2? What's the same? They're both concave down, but what's true about your coordinates? The y values are the same, okay? The y values are going to be the same. Are they positive or negative? They're positive in those two quadrants, okay? If we look at 3 and 4, again, the x's are different, but the y values are the same, okay? And they happen to be negative, all right, in those quadrants, right? So in this one, y was greater than 0, and this one, y was less than 0, okay? That just is based on the quadrant that they're in, okay? So two things that are the same. Now, we know that concavity for calculus revolves all around what? Second derivative, okay? So they told me that the second derivative is negative 4 over 16y cubed. How does this support what we noticed about concavity? Okay, well, let's see. We know we are concave down when the second derivative is less than 0. Okay, so we know we're concave down when it's less than 0. If we look at the quadrants that it was concave down in, so 1 and 2, all right, what's going to determine from the second derivative if it's positive or negative? If the derivative itself is positive or negative? Okay. It all comes from that y value that's sitting there, right? Because y is cubed in that formula, right? So negative 4 over 16y cubed. If I want the entire derivative, all right, to be negative, what has to be true about that y value that we put in there? It has to be positive, right? Because I want a negative divided by a positive. So we would say that that is less than 0 when y is positive. Which is true in quadrants 1 and 2. Okay, for this problem. Likewise, if we're looking for where it's concave up, we know that means the second derivative is positive or greater than 0. Well, that's only going to happen based on that derivative formula, the second derivative formula, when I get the entire derivative is positive. Well, if that's going to happen, what's got to be true about y? It's got to be negative. If I cube a negative, I get a negative. A negative divided by a negative is a positive. So that's going to happen when y is negative, which agrees with what we found for Q3 and Q4. Okay. So when it comes to the AP exam, there are certain things they expect you to be able to do with implicit relations. Okay. And our questions that involve implicit relations, here are the things that they're going to ask me to do. Okay, these are the things that they are going to ask me to do with an implicit relation. Okay, one, they might ask me to prove the derivative's true. Okay, which we did back earlier in Unit 3. Okay, they might ask me to write an equation of a tangent line. Right, again, what we did in Unit 3. They might ask me to write equations of vertical and horizontal asymptotes. And we're going to talk about that here in a second. Actually, I think that meant it's supposed to be tangents. I think I wrote that word down wrong because I got excited. And then they might ask me to identify extrema. And concavity. Okay, so these are the basics. These are the basic things they're going to ask me to do with something that's implicit. Right? Prove a derivative is true. Maybe write an equation of a tangent line. Maybe do equations of vertical and horizontal tangents. And then talk about extrema and concavity. Okay, so what we're going to do is we're going to take one implicit relation and we're just going to do all the things. All right, we're going to do all the things that it asked me to do. All right, more than likely this is a free response question. In fact, you can kind of count on it will be a free response question. All right, that's what they're going to ask you for. So we're going to work through some things and we're going to have to get creative. All right, we're going to do some creative algebra today. All right, are you ready? No. Well, we're going anyway. Okay? All right, I love you, but we're doing it anyway. All right, here we go. So let's take this implicit relation, 4x squared minus 4xy plus y squared plus 8x equals 12. First thing they want me to do is to verify the derivative. Okay, they gave me dy dx. In other words, show me the work that gets me there. Go. I was like, man.
That is the best I can do, I'm sorry.
Anything special we're going to have to do while we're doing this derivative? Yeah, there's a product rule here in the middle. All right, negative 4x and y. We'll have to do product rule on that piece. Okay, so let's start. 4x squared will give me 8x. All right, I'm going to keep it plus. And then we're going to take first, which is negative 4x, times derivative of y, which is dy dx. All right, plus second, times derivative of the first, which would be negative 4. So there's your product rule. Then we get to y squared, which would be 2y dy dx. 8x would be 8. And what's the derivative of 12? 0. Be careful. That's the most common mistake. All right. We're going to combine what we can. So this is going to give me 8x minus 4x dy dx minus 4y plus 2y dy dx plus 8 equals 0, right? Let's move everything over that does not have a dy dx to it, all right? And so if we do that, then we factor out everything else. I have negative 4x plus 2y dy dx is going to equal negative 8x plus 4y minus 8. Okay? And so, I bet that's Gareth. So if we divide, that gives me dy dx is going to equal, again, looking at the order, it looks like they kind of switched the order of the x and the y. So I'm going to go ahead and do that. 4y minus 8x minus 8. How'd you do? Make 100?
Probably not.
Oh, dang. Over 2y minus 4x. Okay? We seem really close. All right? We seem really close. What seems to be the issue?
It's not reduced.
It's not reduced, okay? And when you're showing all the steps, they want you to show what you did. So on the top, I would factor out a 4. Can we do that? Or a 2? A 2. Yeah, looking at what we've got left. We'd factor out a 2. And that would leave me with 2y minus 4x minus 4. On the bottom, a 2, y minus 2x. And then my 2's would cancel out. So I get dy dx is equal to 2y minus 4x minus 4 over y minus 2x. All right. So they're going to want to see all your work, probably worth 2 points. Okay, if I had to guess in the free response. Okay, so that's the first type of question they would ask. All right, here's the derivative. Prove that's really what it is. Okay, show me all the work. All right, oh, he's broke out the beer again. It's a bad day. Start with a test, then you got to go to calculus and bring on the ginger beer.
How do you open that, bro?
If he starts carrying around a bottle opener, I'm going to be worried. Oh, have you got one? Okay. All right. Okay. Gareth's weapon in his wallet. Y'all be careful. He'll get you.
Barely scroll out.
It's not, well, okay, I've only been flagged with it at TSA once.
Once. Okay.
Gone through TSA like
Just one time. All right. So let's look at this one. Okay. So this one changes a little bit. We still have the derivative. They gave it to me. We know it's true. Okay. It wants me to find the equations of the lines tangent to the graph at its x-intercepts. Whew, that escalated quickly. All right, so we're going to do tangent lines. To do tangent lines, we need slope and we need a point. Okay, well, the good news is they gave me the slope. Right, but we've got to figure out the points. All right, now let's talk about x-intercepts. When do x-intercepts happen? When y is equal to 0. We're talking about the original function, okay, when y is equal to 0. So I'm going to take this original function, and I'm going to plug in 0 for y. Okay, so that gives me 4x squared minus 4x times 0 plus 0 squared plus 8x is equal to 12. Okay, now this was probably all chosen on purpose, all right, so that I could work through it. So that's going to give me 4x squared plus 8x is equal to 12. I'd really like to be able to solve for x. All right, recommendations. Make it equal to 0 and pray we can factor. Okay, this would be on a non-calculator section, so it's probably going to factor, right? Anything you can pull out or divide out. A 4, ooh, that's even better. X squared plus 2x minus 3 is equal to 0, right? So what are those x values that we're looking for? X equals, let's see, plus 3 minus 1. And so x is negative 3 and x is 1. Okay, so does everybody agree with that? We found the x values. Now, do we know how many tangent lines are we going to have to write? 2, because we have how many intercepts? 2, okay? So, the first one, my point is negative 3, 0, right? To get my slope, where are we going to put it? In the derivative. Okay, so dy dx is going to equal 2 times 0 minus 4 times negative 3 minus 4 over 0 minus 2 times negative 3. So I'm going to get 12 minus 4 over positive 6, which is, what, 8 over 6? Which is 4/3. Okay, so let's write our first tangent. Tangent has to start with y equals. Okay, so y equals my slope, 4/3, x, opposite of my x value, plus my y. You can put the plus 0 on there if you want to, but you don't have to. Okay, so there's 1. All right, let's do the second one. What's my point for the second one? 1, 0, because it's an x-intercept. Let's get our slope. We're going to plug that into dy dx. It's going to equal 2 times 0 minus 4 times 1 minus 4 over 0 minus 2 times 1. Which would give me negative 4 minus 4 over negative 2, negative 8 over negative 2, which would be positive 4. Okay, and so my last tangent equation, y equals 4 times x minus 1. You can put the plus 0 if you want. Okay, so a lot more detailed in that step. Okay, they got real specific. Not only did they want tangents, they wanted tangents when at the x-intercepts. So we had to do a little extra algebra in the beginning to find our points. Okay, kind of like hide and seek. Right? What do you think? You just have to be careful, right? It's not that they're super difficult. There's just a lot of thinking you have to do. Okay, let's look at the next one. All right, how does this one change? So, same graph, same derivative. This time we want equations for vertical tangents, all right? In order to have a vertical tangent, what has to be true about the slope? It has to be undefined, okay? Slope is undefined on a vertical tangent. So we've got to figure out where is dy dx undefined. Okay, now it's a fraction, right? So where would it be undefined? Where the bottom is 0, okay? If my denominator in that fraction is 0, okay, then it would be undefined there. So let's take just the denominator. Where is y minus 2x equal to 0? Well, that's really not going to help me because I got 2 variables, right? But I know y would actually be equal to just what? 2x. Okay. y would be equal to 2x. So let's go back to that original equation and find that x value. Okay, and find that x value. So we're going to plug in some nifty substitution, right, into our original equation. So here we go. 4x squared minus 4x. Instead of y, I'm going to put 2x. Plus, instead of y, I'm going to put 2x squared plus 8x is equal to 0. All right, so we're going to do some solving here. Let's see what happens. Okay, so I've got 4x squared minus 8x squared plus 4x squared. Oh, this is 12, not 0. I don't know why I put 0 there. I was having a brain sparkle. Okay, all right, so let's simplify. Plus 8x is equal to 12. Right? Well, what's going to happen to all those x squares? Ooh, they cancel out. It's my favorite. So I get 8x is equal to 12. X is equal to 12 over 8, which is just 3/2. Okay. So vertical tangents. What do those equations look like when you write a vertical tangent or when you write a vertical line? Just x equals. What did x equal? 3/2. That's my vertical tangent. Okay, so my vertical tangent was x equals 3/2. Okay, so little, again, nifty algebra at the top, right? The calculus. All right, I gotta run down here and tell Coach something. Hang on. All right, y'all try the next one.
Exactly. Just like that one problem from there. From here, even though we both in different directions, we still got the same answer.
Coach left his phone at home. That was his wife. Abe's there with the phone. I was like, okay. Coach Goolsby left his phone at home, and so his son brought it when he came to Ball State.
Yeah. Surely, I think I saw that arrow's down.
Maybe it helps.
There's so many pages. I see so many pages now.
You said there's still 3 pages.
Why? I see. There are effective pages.
Where do we need to start? Let's do that. If we're going to do a horizontal tangent, what has to be true about the derivative? dy dx has to equal 0. Because dy dx is a fraction, what part of the fraction has to equal 0? The top. Okay? So I get 2y minus 4x is equal to 0. This is going to be one of those things where we got to plug some stuff back in. Okay? Let's solve. Oh, I forgot the minus 4. Let's solve for y. This is going to give me 2y equals 4x plus 4, or y is going to equal 2x plus 2. Okay, do we agree with that? Yep. All right. So now let's plug it back into the original function. We got to figure out what the x value is. Where does it happen? We can't write equations without points, right? So here we go. Let's plug it back into the original. So I have 4x squared minus 4x times y is 2x plus 2 plus 2x plus 2 squared plus 8x is equal to 12. Now, I really hope things are going to cancel out and go away because this is getting really nasty really fast. Okay. So let's mess with it. 4x squared minus 8x squared minus 8x. If I square that parenthesis, that's 2x plus 2 times 2x plus 2. It's going to give me 3 terms. So 4x squared, 4x times 2 plus 8x plus 4 plus 8x is equal to 12. Okay. Whew, I hope something goes away. Let's see. This 4x squared, and that minus 8x squared will go away. Negative 8x and a plus 8x would go away. So I think we end up with 8x plus 4 equals 12. Okay, did we get there? All right, so now let's solve for x. So 8x is going to equal 8, or x is going to equal 1. All right, x is going to equal 1. All right, now, when we did a vertical tangent, I just needed an x equals. When I do a horizontal tangent, what do those equations look like? Y equals, okay? Do we know what y equals? 2x plus 2. Okay, so to get my horizontal tangent, I literally just have to plug that x value back in to find y, because all horizontal lines are y equals. Okay, so I would get my horizontal tangent. It's going to be y equals 2 times 1 plus 2, or the equation y equals 4. So take a second, kind of soak that in for a minute. Okay. Vertical tangents are just x equals lines. Once we find x, we're done. Horizontal tangents are horizontal lines, y equals lines. So once I find x, I have to plug it back in to find y. Okay. Now, let's do one where they give me something specific. Okay, so it's not just horizontal or vertical. They get a little more detailed. Same process, all right, but a little more detailed. Okay. All right, look at this one. Same thing, but this time we want to find the coordinates of all points on the graph where the tangent line has a slope of 1. So this is going to be a little bit more complicated. Okay, where dy dx is going to equal 1. All right, not as easy as what we did a few minutes ago. Okay, because dy dx, is a rational function. All right, so I'm looking for where dy dx is equal to 1. In other words, that whole thing, 2y minus 4x minus 4 over y minus 2x is equal to 1. Okay? And the other examples we did, we had to solve for y because there were too many variables, right? How can I solve for y in this one? Yep, they equal each other, so we're going to cross multiply. Okay? We're going to do a proportion. All right. So 2y minus 4x minus 4 is going to equal y minus 2x. Get your y's together, get your x's together. Okay, solve for y. Right. So I'm going to pull the y over first. It's going to give me y minus 4x minus 4 is equal to a negative 2x. And then if I pull the negative 4x and the negative 4 over, that's going to give me 2x plus 4. Okay. All right. What do we do next? What have we been doing? Substitute it back into the original equation. We got to figure out where those x values are. Okay, so that expression for y, we're going to put into the original equation. So 4x squared minus 4x times 2x plus 4 plus 2x plus 4 quantity squared plus 8x is equal to 12. If we're lucky, there'll be just one x value. Okay? Good algebra right here. Let's distribute combined like terms. I think I did all that right. All right, let's see if I can get rid of some stuff. I can drop the 4x squares and the minus 8x squared, the negative 16x and the 16x. So I end up with 8x plus 16 equals 12. Yay, just going to get one. Okay. Pull things around, I'm going to get 8x equals negative 4, or x is negative 1/2, right? All right, I think we're making good progress. What do they want as my answer this time? Coordinates of points, okay? Well, there's just one x, so to get its coordinate for y, what are we going to do with it? Plug it back into y. Okay, so y is going to equal 2 times negative 1/2 plus 4, which would be negative 1 plus 4, which would be 3. That is my coordinate. Whew. Lots of algebra. Okay, lots and lots and lots of algebra. To me, these are those problems where it kind of pulls in everything we've done so far, right, into one problem. It puts it all there. So don't be surprised when you get to your test next week and there's a free response question that's a full one, okay, because we can do that now for this, right? Hint, hint, wink, wink, nudge, nudge. Okay, all right. So here's an example. You think so? I don't know. I was trying to be subtle. Okay. All right, so let's take a look at this one. Okay, this is an actual free response question. I just took out one part. There were 4 parts. I took one out, all right, because we haven't got there yet. Okay. So I want you to start with just A. Let's just do A. Okay, we'll check it, and then we'll move on to the next one. Okay. So for part A, it just wants the equation of the tangent line to the curve at the point negative 1, 1. Okay, to write a tangent line, I need a point, which they gave me. What else do I need? I need a slope. Okay, they gave me the derivative there, so I don't even have to calculate it. I'm just going to plug in negative 1 and 1. Okay, so for part A, we're going to find that dy dx is going to equal 1 over 3 times 1 squared minus negative 1, or 1 over 4, right? So my tangent equation y equals 1/4 x plus 1 plus 1. Okay, that would be worth 1 point. All right, because they gave you everything but the slope. All right, how'd you do? Okay, yay, see? So you're going to get a point on this question regardless. All right, you can do it. Okay, now let's look at part B. Part B gets a little bit more difficult. It says find coordinates of all points on the curve at which the line tangent to that point is vertical. So we're looking for vertical tangents. Okay, vertical tangents, try that one. All right, did we get here? Did we realize that we needed the derivative to be undefined for a vertical tangent, and that that means we use the denominator, so 3y squared minus x equals 0. Okay, you're going to get a point for that. All right, which is good. All right, if you can't do anything else, do something. You might get some points. All right. Now, what should I do next? Plug it into the original. This time we're going to find y, and that's okay. All right, we're going to replace x this time. So we're going to go up to our original. So y cubed minus x we know is 3y squared times y is going to equal 2. All right, so that gives me y cubed minus 3y cubed equals 2, or negative 2y cubed equals 2, y cubed equals negative 1, or y equals negative 1. Okay, so typically it's not difficult once you get in there to solve. Okay, now we want to be sure we give the answer that they're looking for. Okay, they want points on the curve. All right, well, I know the y value is negative 1. Where do we go to get that x value that I need? 3y squared equals x. So 3 times negative 1 squared. So what would x equal? 3. And that's my point. Okay. All right. Okay, that was worth 2 points. All right, you got 1 for solving for that 3y squared equals x, and then a 1 for your answer at 3 and 8. Maybe it was worth 3. I can't remember off the top of my head. Maybe it was 3. You get a point for negative 1, and then for, and now it's 2. 1 for 3y squared equals x, and 1 for the answer 3 negative 1. Okay. Part C. Evaluate the second derivative at the point on the curve where x equals -1 and y equals 1. Okay? So basically all they're asking me to do is take a derivative and plug in some stuff. Okay? But it's not going to be easy stuff. All right? So let's do the derivative. Okay? So for part C, let's take our first derivative, which was y over 3y squared minus x. And we're going to take a derivative. When I take a derivative this time, quotient rule. All right? Got to use quotient rule, and it's implicit. So anytime you do a derivative of y, you got to put that dy dx next to it. All right? So d squared y over dx squared. All right. Ho d high minus high d ho. Okay. Over ho ho. Now, here's the beautiful thing. They're not asking me for an algebraic representation of that derivative. They're asking me for the second derivative evaluated at this point. Do not simplify, plug in. Okay? Plug in. You're going to save yourself a lot of heartache and an algebra mistake. Okay? So as long as you do that derivative correctly, we can stop right there. Okay? So how would that work? Well, here's what we would do. D squared y over dx squared. All right? Get my point. 1, -1. Okay, I'm going to write it right here. Oh, -1, 1. Okay. Stop. Okay, so I'm going to plug it in. So this is going to give me 3 times 1 minus -1. Now, I'm going to multiply it by dy dx, okay? So let's go back. What was dy dx? Well, it was y over 3y squared minus 1. And guys, we did that in part A. All right, we plugged in -1, 1, hint, hint, hint. What was the slope we got? 1/4, okay? So you're looking to use something you've already used, which is nice. So I get 1/4 minus, okay, y is 1 times 6 times 1 times 1/4 minus 1 all over 3 times 1 squared minus -1. Okay, and at this point it's arithmetic. Okay, now on the actual AP exam you can leave it like that. All right, you do that in college and your professor will cut your fingers off. Okay, they just will. So let's simplify. 3 plus 1, that's going to give me 4 times 1/4. Minus, that one's not going to be important. 6 times 1/4, that'd be 3/2 minus 1 over 4. Okay. So this is going to give me 1 minus 3/2 minus 1 is going to give me 1/2 all over 4. Okay. Oh, I forgot to square that bottom. That's 4 squared. So that's going to be 16. Okay. On the top, I'm going to get 1/2, and I'm going to divide it by 16, which is going to give me 1/2 times 1 over 16, which is 1 over 32. Right? So those are your basics in terms of a free response question when it comes to implicit. All right. Oh, the next page I added 2 things. All right, just to keep it interesting. All right. Push a little bit, look at a few different things to go with it. Okay. Ooh. Okay. This is good stuff right here. I love these. Okay. Jawak, it's okay. Deep breaths. That does not help in labor, but maybe it will help on the AP exam. Okay? Just putting that out there. All right.
Let me get the shirt for the AP.
What shirt are you getting?
I think it's how to calculus or something along the lines. I remember us talking about it earlier.
Yeah. Look at the problem. Read the problem. Cry.
Exactly.
That's the one. Okay. All right. So let's look at this one. Let's see about what it tells me. It says, it can be shown that the second derivative is greater than 0 when x is less than 0. Okay? If the tangent line in part A is used to approximate the y-coordinate of a point on the curve when x equals negative 1.5, would the value be an over or under approximation? Give a reason for your answer. Okay? Well, you got a 50-50 shot, all right? Which is good news, all right? That's better odds than the lottery, okay? You got a 50-50 chance. But let's talk about what it means, okay? The second derivative is positive. What does that mean about the function? It's concave up when x is less than 0, when x is negative, okay? All right. So we don't know what this curve looks like, okay? But over here on the negative side, it is concave up, okay? My tangent line, we're going to do at negative 1.5, okay? So if my curve is concave up, okay, and my line is underneath, what kind of approximation we're going to have? It's an under approximation. Okay? It's an under approximation. It is underneath. So this is why we say it's true. The approximation at x equals negative 1.5 is an under approximation because d square y dx square, basically you're restating the problem up top. It's greater than 0 when x is less than 0, meaning the graph is concave up. At x equals negative 1.5. Okay? That's what it means. You're just telling them what all those words mean. Right? So that's not terrible, but you just got to remember that. You got to remember what the derivative tells me. Okay? And what the tangent line would look like. It's okay to sketch something. That's not your answer, but it's okay to sketch it. All right? If it helps you remember. And then we talk about why it's true. It's concave up. All right? Why is it concave up? Because the second derivative is positive when x is negative. Okay? That's why it's true. All right. Last one. All right? Last one. And I don't know if you remember, but in Unit 3, we had a question kind of like this, and we struggled a little bit, all right, with this. Some of you finally got that one right, but I pushed you a little bit. Okay? Is there a point on the curve where the tangent line is horizontal? Okay? Is there a point on the curve where the tangent line is horizontal? In other words, where dy dx is equal to 0. Okay? So in that derivative, which part of the curve, or which part of the derivative would have to equal 0? The top. Well, what was the top part? It was just y, right? So means y equals 0. Bless you, bless you. Okay? And then how do I find the point on the curve? Plug it into the curve. Okay, we plug it into the curve. And our curve was what? Y cubed minus xy equals 2. It was in that very first part. So y cubed minus xy is equal to 2. Okay, if we plug in 0, 0 cubed minus x times 0 equals 2. 0 minus 0 equals 2. 0 equals 2. Is that true? No. Okay, so our answer, is there a point? No, there is no point on the curve where the tangent line is horizontal. Okay, give a reason because there is no x value where y equals 0. That's it, that's why. Okay, we plugged in 0 for y, there's no x that works. Okay, so there's no x value where y is equal to 0. Whew! It's a good way to wrap up this unit, okay, because it talks about everything we did in Unit 5. Okay, it wraps it all up. So your lesson practice is a worksheet, all right? Behavior of implicit relations. I think I pulled it all from AP Classroom. Okay, just because they're good questions. Okay, I don't want to lie, but I think it's like 5 or 6 questions. It's not a bunch. I probably just lied, though, because there's 4 on the front page. Hold on. 6. A 6! Yay! I didn't lie too bad. Okay, so there's 6. All right. And then your wrap-up is there on Google Classroom. Let's get that done. Okay. We did have one yesterday. Did we? No. Yes. No. We did not have one yesterday. We have one today. Okay. I had to think about what we did yesterday. Okay. Tomorrow we'll start your review. All right. So your progress checks will open, all that good stuff. I know.
What, you have a quiz or 512 on Monday? Or is that our test?
You have a test Monday. Yeah, we're not going to do a quiz over 510.
Oh, good.
Okay.
I guess I'll
Okay.